So today you're going to be matching up graphs with their equations. So I feel like we need to talk a little bit about how an exponential equation is formed. So they use the formula f of x equals a times b raised to the x. So what are our a and b values representing? A is so initial value is what they use. Graphically, what does the initial value look like? That's it. So our initial value is what happens when the x is 0. So that is our y-intercept. Notice this is only true when the exponent is only an x. If this is x minus 1 or x minus anything else, this is not the initial value. If it's x plus anything, right? Or in other words, this is not the y-intercept, is what I'm meaning to say. Right, so make sure it's in this form where your exponent is only an x. And then what does the b represent? It's growth or decay. How do you know which is which?
Decay is less than 0. No, yeah, 0 to 1.
That's it. So it's decaying if the value is between 0 and 1. So 0 is less than b is less than 1. That makes it decay. And it grows if our b is greater than 1. If that b is negative, what do you guys think that would do? Think about transformations of graphs. It's a reflection. And it's on the inside, right? It's in there with the x. So just kind of getting an idea that that's kind of where we're headed. All right? Are there any questions about this so far? So originally, I was planning on skipping the lesson we were going to do today and let you guys work on it Monday because it's a matching graphs type thing. But then I looked at the next lesson and it depends so much on this lesson that I don't think I can skip it. So I was trying to be lazy and not record a lesson for Monday, but I guess I'm going to have to record one. Like I said, to start with, this is a matching assignment on the exponential matchup. There are two ways you can match them up. Okay, I think in your packets you should have a print off of there's 2 pages of graphs and 1 page of equations. You guys see that? So the first 6 questions are all about that first page of graphs, A through F. And then they ask you some questions about that. And then the next 6 are the back graphs. So with these matching things, I know I stink at this. I'm going to need to give you a second to try to match them up yourselves without me walking you through every bit of it. So I've got to shut up. I'm not good at that. So I'm going to give you time to do that. Let's try to do numbers 1 through 4 first, and then we'll check in, make sure that we're in a good spot before you guys start trying to do 5 and 6. If you're already finished with 1 through 4 and you feel really confident about it, and you want to go ahead and do 5 and 6, go for it. Like I said, we'll come back and talk about it in, I don't know, I'll check in 5 minutes and see how it's going. You think A is money symbol. Why?
Okay. I looked at the graph for A, and I saw that if 0 was plugged in, we got 1. And if 1 was plugged in, we got 2. So I did that, and it worked. The donut dropped.
Uh-huh.
And that's what I've been doing for all of them.
That sounds good. Notice, so like on money sign, what is my A value? It's not 0. There's an understood 1 there, right? Because there's no number being multiplied in front of the exponential. There's an understood 1 in that spot, which means the y-intercept is 1. We could always write it as 1 times 2 raised to the x.
Yep. But when you just said that, doesn't help anybody because all of these y-intercepts are 1 on the first page.
So what I'm telling you is, if it has a number in front,
It's
it's not going to be the answer either. Again, I'm trying to pass these subtle hints. Okay, so like when I look at A, like the things I would look for, the y-intercept is 1. Right, then I would think, what is it when I plug in 1 for x? If I plug in 1 for x, the y value is 2. So that means whatever it is raised to the first power needs to be equal to 2. Okay? So what raised to the first power is 2? 2. So it's going to be 2 raised to the first. Well, let's see, did that work if I raise it to the second? What's 2 raised to the second? 4. What's 2 raised to the third? 9. So this one's going to work as 2 raised to the x. Is it increasing or decreasing? Is it concave up or concave down? Y'all good with answering those questions from the... So the hard part's matching? So if I look at B, again, the y-intercept is 1. And now what am I getting if I raise it to the first power? So it's going to be something raised to the first power. It's got to be, I don't know exactly what that is. It's some kind of fraction. Looks like it's less than a half. You with me? So what I would do then, I would go the other direction. What if I raise it to the negative first power? I get 4. So what raised to the negative first is 4? So what does a negative exponent do? Yeah, so negative exponents they work as like reciprocals. They flip the number. So what would I need to raise to the negative first to get 4? Yeah, you with me? 1/4 to the negative first is 4 because a negative exponent is a reciprocal. So I need the argument to be I need this, I call that the argument. I need that number to be 1/4 x. And so what would happen if I raise this to the negative second? I should be at 16. Well, that looks like that could be viable. If I raise this to the first, I should be at 1/4. Well, that's about where that is. To the second, it should be at 1/16. All right, so that fits everything I need. Is it increasing or decreasing? And is it concave up or down? Up. Does that help a little? Can you...
I figured it out about when you started talking about it.
That's good. How do you feel about C? Okay, which equation was C? Asterisk. I agree. It's the asterisk symbol, which is 1/2 raised to the x. That one's very similar to the one I just worked on B, right? Where we're getting we're decreasing every time. Do I need to explain how to get that one?
Yes.
So, again, these are all kind of boring because the y-intercept is 1. So like there's no number being multiplied out in front. So that one doesn't help me. So then the next thing I like to do is I like to go to the first power. So if I raise this to the first power, I need for it to be some fraction. I don't know exactly what the fraction is, but it looks like it's around a half, right? It's around 0.5. But that's not enough information for me to be for sure that it's a half. It just looks like it's around a half. So then I would go in the other direction. What if I raised it to the negative first? So if I took this number and I raise it to the negative first power, I need to get a y value of 2. So some number raised to the negative first is 2. That one I know for sure. And so remember, negative exponents work like reciprocals. So what would I need to raise to the negative first to get it to be 2 over 1? Well, that number would need to be 1 over 2. Is that where you're stuck? What's 3 raised to the negative first? Do you know? Okay. So negative exponents, we can rewrite them as positive exponents by moving it to the denominator. So 3 to the negative first is 1 over 3 to the first. Okay, if I have 3 to the negative second, we can write that as 1 over 3 to the second, which is 1/9. So how do negative exponents work? That's the confusing part. Okay. 5 to the negative second. That would be 1 over 5 to the second, which is 1 over 25. If I had 2/3 raised to the negative first, so what am I doing here? This is like 3 over 1, right? And I'm just flipping it. 5 over 1, and I'm just flipping it. So 2/3 to the negative first would be when I first show that, here's the way I kind of explain it. I want you to think about it in terms of place values. So you learn about place values when you're in elementary school. So the first place value to the left of the decimal is the ones place, tens, hundreds, thousands, 10,000s. With me, 100,000s, millions. All right. Then what comes to the right of the decimal? The next one is the tenths, which we can write as 1 over 10. And then we have the hundredths, which is 1 over 100. And then thousandths, and so on in both directions. Okay with all that? So it's the reason that we go by tens is because we're in a base 10 system. There are 10 different digits we use. 0 through 9 are the 10 different digits. So tens is 10 to the first, 100 is 10 to the second, 1,000 is 10 to the third, 10,000 is 10 to the fourth, and so on, right? We know that. That makes sense to us. Now start working the other direction. So what's the ones place need to be? 10 to the 0, because anything to the 0 power is 1. And then what comes next? So 10 to the negative first is a tenth, and 10 to the negative second is 1 over 10 squared, which is 1 over 100. Is this making a little sense? Maybe for how the place values work with the negative exponents? To me, this is what made sense to me, that, okay, I know why the negative exponent does, and it makes sense that it should follow that pattern. So, I like to use positive exponents, but whenever the positive exponent doesn't happen on a crosshair, you know what I'm talking about when I say on a crosshair, then I don't know exactly what that value is. So, like, I guess this was close to a half, but I've got no way to really know it's a half. So I had to go in the other direction to get a negative exponent. when I went to the negative first, I was right on the crosshair of 2. And so then, what I had to do then was I had some number, the x value is the negative first, and it has to equal 2. So what can I raise to the negative first to get 2? Does that question make a little more sense now? So negative exponents work as reciprocals. So this number would need to be 1/2 raised to the negative first. Could flip it to become 2 over 1. Okay. D. Okay, a little more interesting. The y-intercept is -1. So I know this is going to be -1 times some number raised to the x. So I need a negative out in front. And now what if the x value was 1? What am I getting? I'm getting -2 in total. Right, but this negative is taking care of that out here. And then if I raise it to the second, I'm down to a 4. So that's going to be -1 times 2 to the x, which is which one of those equations was that one? Oh, I got you. The at symbol. No. Sorry, I'm stuck in my dial-up internet days. So what's different about what I wrote versus the at symbol? Yeah, they just didn't put the 1. Right? But it's the same thing. There's an understood 1 out there, out front. I'm gonna harp on this for a second. -2 to the x and -2 to the x are different. Okay, so if you think about it, what would happen if I plugged in a 2 here? What is -2 squared? +4. But if I plug in a 2 here, -2 squared, this is 4 times -1, which is -4. So those are different equations. So just beware of that. Anyways, so for D, was it increasing or decreasing? It's decreasing. Concave up or down? Down. We didn't do this for C, did we? C was decreasing and it's concave up. We good with that? Yeah, I act like that wasn't the problem. Okay, E. E is similar to B and C. Ready? We see that right off the get-go? Y-intercept is 1. And if I go to the right one, I'm at a decimal. So if you have to estimate that decimal, what's your estimation? Less than a half will be my estimate. Right? It should be less than a half. That's about all I could get from that. All right, so what am I going to do then? I'm going to go in the other direction. So if I plugged in a -1 as the exponent. So what number raised to the negative first is 3? 1/3. So I need this to be 1/3 raised to the x. Is that a choice? No. So this is a correct equation, but it just doesn't match any of the choices that they give me. So, yeah, so what would be 3 to the negative x? 3 to the negative -1.
Yeah. 3 to the negative x is one of the answers.
Yeah. 3 to the negative x. So if you think about it, if I plugged in a -1 here, if my x is -1, What is negative negative 1? Positive 1. 3 to the positive 1 is 3. So when I plugged in negative 1, I still got 3. Anyways, that's probably the most confusing one. So what they're wanting you to learn there is a negative in the exponent is working very similarly to a fraction in the B position, in the argument position. Right? So like on B and C, when I had a fraction being raised to x, that looks very similar to a whole number in that position, but a negative exponent. Following that? Those are the same transformation. That's what they want you to get. Increasing, decreasing. Decreasing. Concave up or down? Up. Okay, then what about F? It is the exclamation point. Is that one easy enough to figure out why, hopefully? That's the normal way that an exponential graph looks. So if it looks like this, there's not going to be too much funny business happening. Increasing and concave up. Okay? So number 2, how can we tell from an equation whether the function is an exponential growth or an exponential decay? If the b is greater than 0, it's which one? What did you say?
I said the b is greater than 0 but less than 1.
Okay, if the b is greater than 0 but less than 1, it's which one? Decay. And if the b is bigger than 1, it is growth. And we know what that looks like graphically, right? If it's a growth problem, it's going in this direction from left to right. If it's a decay problem, it's working down from left to right. Right, that's the difference between increasing, decreasing. 3, one extra equation card turned up that wasn't part of your original set. Which graph would this match with? And how do you know? So if we added y equals 2 to the negative x. How do you know?
Because exponents are work as reciprocals, and 1/2 is the reciprocal of 2.
That's it. And then 4, why is it possible that one graph could represent 2 different equations? Well, because exponents have all these weird properties, right? And you can rewrite them different ways based on your exponent rules. So like right here, they show you on 3 one way you could rewrite it. So if I started with 1/2 raised to the x, when I raise something to the x, I can rewrite that as everything being raised to the x. So that's what they've done here. And now what is 1 raised to any power? What's 1 raised to the 3rd? 1 raised to the 5th? 1 raised to the millionth? So 1 raised to the x is just 1. And so that leaves me with 1 over 2 to the x. Well, if I have 2 to the x, if I have an exponent in the denominator, and I want to move it to the numerator, how can I do that? Change the sign of the exponent. If it's a positive exponent in the denominator, I could move it to the numerator and make it become a negative exponent. And so what's 1 times 2 to the negative x? It's just 2 to the negative x. So 2 to the negative x is the same thing as 1/2 x. They're showing you that algebraically. You've just seen it graphically, that they have similar outputs. And here algebraically is how you could manipulate that equation to look like that. Okay, try 5. Do we know which graph is G? You put pi? They didn't put pi. Let's say down which one? V? So the exponentiation? That's not what they put either. So let's look at those. Give me a second. Give me a second. Huh? Copyright. We're not gonna have time, are we? Dang, nabbit. So which ones did y'all say you thought it was for G?
Well, I thought it was the,
Pi?
because I just looked at it twice, it was at a half.
Okay. So the problem with pi, look at if I plugged in a 3 for x. So according to the graph, if I plug in a 3 for x, I should get out a 4. If I plug in a 3 for x at pi, 2 to the third is 9. 9 times a half is 4.5. You see that? So it's not going to line up perfectly with pi. The other one was the exponent.
I think I just fixed it.
Okay. Yeah, so like if I plug in a 1 for x, that one works. But if I plug in a 2 for x, I should get out a 3, according to your equation. But on here, I only get a 2. Dang it. Okay. Well, whatever.